Hello, everybody, and welcome to the Let's Talk About Data. God, my head's gone. Let's Talk About Data show. I've just been drinking some coffee, so I think it's just inducing in me and getting me excited.
We think it's coffee, right?
Yeah, it's coffee. I've got coffee. just coffee, and
All right.
we'll have a little sip of it. We're just chatting backstage as well. This is our 100th episode, so what a huge event for us. We're really excited to have a great topic on as well for our 100th episode. So we're going to be doing building at scale with Aurora DSQL Essentials. So I'm Tony Mullen, one of your regular show hosts. You've probably seen me on here a ton of times over the past 2.5 years, but we've got two great guests today. So I'm going to let them introduce themselves. So Shyam, do you want to go first?
Hi, folks. My name is Shyam. I'm the director for the Aurora DSQL team. Been in AWS 15 years right now. Really fun ride. Been working on this product for the last 2 years. So good morning, good afternoon, wherever you are. Excited to talk about Aurora DSQL with you today.
And hi, everyone. My name is Mark. I'm a senior principal engineer on DSQL. Also been with AWS for 15 years and just super excited to be here. Thanks for having us, Tony.
No, great for you to be here. 15 years, Mark. Wow. That's impressive.
Yeah.
3 years. It's 3 years for me. I think it is in a couple of weeks. So 15 years.
He's the expert I bring along anytime I need saving and rescuing.
Yeah, he knows his stuff. It's going to be 15 years. That's really good going. Excellent. And we've got Prasad as well, one of our other show hosts. He's on chat support today. Going to be helping us throughout the show, popping lots of links in there for you. And, as we go through the show, things we can share with you. I'm just quick look who we've got in here. So we've got some people saying hello already. So Eerie Edits, coffee. Yes, coffee's great. It's no good when you get a little rush like that, though. It confuses you a little bit. And hi, yeah, good to see you. Prasad as well. I say chat support today. Crazy DB8, he's one of our regulars. Excellent. Good to see you again. Yeah, thanks for the 100th episode. Good morning for Peru. Excellent. So, yeah, I'm from Manchester. I always like to get it in there, Manchester, UK, because it's usually dreary and wet and not very nice. And that's definitely like that today, even though it's summer, which is very strange. Where are you two guys coming from today, tuning in from? How about you, Mark?
Yeah, we're both in Seattle. Actually, if I look straight through the wall with my X-ray vision, I can see Shyam.
So you got back-to-back offices.
Yeah, from Seattle. I'm actually originally from Cape Town, South Africa. I joined AWS to work on EC2 out of Cape Town. I've been in the US for about 7 years. So west coast of the US now.
Excellent. So Seattle's pretty dreary as well, isn't it? Seattle isn't not like Jeff, who's our producer. He's in LA. Lovely sunny weather.
When we have summer in Seattle, it's great.
That gray wall is actually not a wall. It's just looking through the background.
It's just the window. Yeah, not the best.
Yeah. No. I spent half my life here. But grew up in South India and then sort of westward all the way.
Excellent. So you've been in Seattle a good while then.
Yeah.
So, yeah, excellent. And
congratulations.
Say that again. Sorry.
Are you trying to say he's old?
Actually, you know what? As soon as I said it, I thought, don't catch on to that. He's gonna kill me. No, not at all. He's looking at 35, I'd say. So, I mean, I'm old. I'm getting on there now. It's just when we were talking before about pages being called out, that really shows your age. So,
yeah.
100 episodes already. Another one from Minnesota. Hi, good to see you on here. And hello, Data Explorer Days. Victor. Good to see you again. And
nice to meet you.
Another one in LA. Excellent. Just showing off there, LA. Manchester's a great place. It's just not very warm. So what's this we got? Can someone revoke the free virtual instance for inactivity purposes or depend on an active state for dynamics? What's this? Free virtual instance for inactivity purposes? Not really to understand what that is, to be fair. Post a little more on that, Victor, and Prasad will reply to you on that one. And learned a lot. Thanks for sharing. We really enjoy sharing information with you guys. It's probably the key thing to the show is that building community, enable new builders to move forward. That's what we are on the show. All the hosts, we're all builders. We all love building. So great to share with you. Anyway, the topic today, let's get going because we've got a ton of stuff to share. We've got some really cool demos as well. So I'm really keen to get this rocking. So let's start with, DSQL. People have probably seen lots of information about DSQL out there. It is, I guess it's the new toy out there, and it is really exciting. People are excited by it. But where did it start? Where did the idea come from DSQL and the history of it? Could you just enlighten us a little bit on that, Sham?
Yeah, I'm happy to do that. We went to DB Engines. There were 299 options. We figured, gotta round it up to 300. I'm just kidding. You talk about old school, customers, and the industry is built over 40 years. Ton of marvelous database engines. But the sort of the cliche in the reality also is that we listen a lot to our customers. A lot of what we're building really comes from what our customers are asking. And over the last 5 to 10 years, sort of two almost divergent requests have come in for customers for saying, hey, can you help us really take these sort of two really hard but undifferentiated to our business problems off our plate? On one hand, you had sort of customers with high availability, high resiliency needs, even a single second of downtime, whether it's a planned downtime because you're patching or upgrading, or unplanned downtime. Things fail in, physical hardware all the time, and they just don't want the database to fail at all. Their business depends on being up all the time. So we had this really ask to say, can you build a high availability, highly resilient database by default, and even one that'll not go down if an entire region is unavailable or unreachable. So a multi-region solution. So that was one side. On the other side, a lot of customers were really finding value in the effortlessness of our serverless databases, Dynamo, or serverless services such as Lambda, because you can essentially start with that database. It grows with your business. It's a business you can just start with. And if you want to think about scaling, there's no sort of bumps in the road. It just scales for you. If you think about management, you don't have to manage it. It's a fully managed serverless capability. And if you're not using it, it just scales to zero. You only pay for what you use. And so they wanted these two properties. And, right around that, then we also had this sort of convergence of a lot of technologies we were using internally at AWS at scale, from high precision, clocks, from internal services such as Journal, which are used by S3 and Dynamo. So we sort of built on that technology and built Aurora DSQL, where D sort of is the distributed part of SQL. So right now, if you want to just look at this slide, we have essentially three databases offered as part of Aurora. You have Aurora Postgres, Aurora MySQL, and Aurora DSQL now is our distributed SQL offering in that portfolio. And 10 years ago, again, sort of that history is, Aurora really pioneered bringing high performance to relational databases in the cloud, right? Customers had been using RDS and getting the value of both commercial and open source databases. But Aurora took that storage layer, really made it a high performance, distributed, multi-tenant, scalable storage layer. And that provided, essentially great price performance, great management and ease of use. And so what we're excited is, 10 years on, you've got your 100th episode, 10-year anniversary. We added DSQL to our portfolio and really took that sort of distributed SQL to the full extent, where we can provide a serverless, scale from zero, scale to virtually, infinity, and give you that high availability, high scale experience. So long answer, but hopefully that gives you sort of that.
No, it definitely, that's definitely good, because you can start to see some of the main advantages of using DSQL. Anybody who's managing a database, and you can tell them, look, we in AWS tell you to plan for failure. We really do. But right. How many databases can, when you're thinking about planning for failure and failure happens, there's different ways you can handle failure. But, if you can get to a point where like DSQL can, where you can fail across regions, as well as in region as well, it's not just a multi-region thing. It is in region. So, it's a real compelling use case for people, isn't it?
Yeah, and even personally, in my previous team, so I've done a few different teams at AWS. Data always came back to the center of sort of the power of and value for businesses comes from that data, and having databases that are resilient. So it's almost like even when I joined the team, I was sort of like personally, I had been looking for something that had the power of relational databases, transactional databases, but sort of that high availability, effortless scaling that some of our serverless properties offer.
And the other bit as well, the scale bit as well, is key as well, isn't it? Not just the failure bit, it actually being able to scale up is a really important bit as well.
Indeed.
That's really cool. So I think we've got, like I say, we've got a few demos. Have you got any more slides you want to show us, Sham, before we move on to the demo?
Yeah, I thought I'd set the stage. So Mark's got, we'll go super deep, hands-on. Mark's got some lovely demos. I thought I'd share a couple of things just to sort of set the context and the frame. So I talked about the motivation. So what does that do? Like, what does it manifest itself? Is when you think about Aurora DSQL, we get sort of virtually unlimited scalability, right? So you can go all the way down, but when you think about a database, you have lots of dimensions on the workload. You've got reads coming in, writes coming in, fairly complex transactions. This is a relational SQL database. So you get, multiple tables, joins, transactions, and sort of ACID, and we'll go a little bit more, atomic, consistent, isolated, and durable. These properties can make it fairly complex, and being able to scale from 0 to virtually unlimited levels on any of those dimensions independently is a key property that you get when you sort of take the database and sort of distribute it and make it a fairly serverless property. And it also gives you sort of that zero infrastructure management. A lot of customers talk to us and said, hey, look, we've got hundreds of databases that we're managing in the cloud. Every time we've got to patch it or upgrade it, we've got to think about a very complex orchestration going through, how do I get, upgrade half of my databases, manage the failover, think about how my applications are going to deal with the few seconds that it takes to do the failover, and just not having to think about that. And returns a lot of cognitive work for businesses back to their primary business, whatever that be, financial, gaming, healthcare. So many different industries really need this capability. And as I said, we built this also for sort of providing that sort of, do you have a database that can stay up even if an entire region is unavailable? But we also have single region mode. So you get single region mode with 4 nines availability, multi-region mode with 5 nines, automatic failure recovery. And we wanted to make it easy to, get started and easy to use. So you can use your standard Postgres drivers, standard Postgres clients. It speaks the Postgres protocol. So Postgres is sort of part of the architecture, runs Postgres. So if you look at this architecture, there's a lot of text here. I'm not going to go through that text, but I want to throw this out there because if you think of a traditional database, right? However it's architected, you always need to do four-ish functions. There's clients that are connecting, so you got to manage that connection. You have to think about how do you authenticate that, how do you authorize that, and how do you maintain those connections over time as requests are coming in, using Postgres, JDBC, ODBC, etc. Then you've got query processors. These are the ones taking your SQL query, parsing it, analyzing it, planning it, and figuring out how to execute that transaction. And when you're committing data, you've got to actually make sure the isolation properties and the immutability properties are held. So you have a transaction processor that's really looking across all the transactions that are coming in and making sure that they are not conflicting and there's correctness when you write data to a database. And lastly, you have storage. All your data is in storage. And so what we do in DSQL is we really take those layers, and all of these layers are large fleets that we manage, multi-tenant, distributed. And when you set up a cluster in DSQL, it's actually a virtual abstract collection of resources across these. What that gives you is a great property. There's no single point of failure. There's not a single instance that's running and saying, hey, what happens if it fails? We take care of the fact that when the request comes in, it's automatically load balanced. It's landing on one of many hosts. If it needs to be distributed, if you need to open 10,000 connections, great. It just happens, right? Yeah. As the requests come in, we're dynamically assigning query processor for them. and they are preloaded with your catalog from a pool. So we're sort of managing that, looking at the concurrency of your application and increasing how many query processors you need to constantly keep up with your application workload. If you think about transaction processors, again, a virtual collection, this is actually built on top of fairly robust AWS, I shouldn't say fairly, really robust technology. And actually running at scale called a journal that S3, Dynamo, many other services use, which is sort of a linearized log that is durable, again, highly available, multi-AZ by default. And then all of that data goes to storage. And our storage, again, is always available in at least 3 availability zones in single AZ mode. When you're in multi-region, it's in both regions as well. And all of these just automatically scale, horizontally as your data grows, as your writes grow, as your concurrency grows. So I just wanted to set that context on what is unique and what is differentiated about DSQL and how it sort of gives you that property that I talked about, right? Virtually unlimited scale. You're not setting up instances. We're just managing and creating more virtual resources for you as your requests come in. That high availability. You could lose, multiple storage replicas. That's okay. We can just recreate them because you've got your snapshots, we've got your journal, we can replay it. And as these are failing, we're bringing up new ones on the thing. And from your customer perspective, from your client perspective, you don't notice anything. It just keeps humming along. And that ease of use, from your perspective, all of this is great, but it just is behind an endpoint. You don't see it, you don't manage it. Just connect to it like you would a local Postgres instance. Instead of local host and port, 5432, you're connecting to the DSQL endpoint, same port, keep going. So just wanted to set that stage. Very excited to talk about DSQL and all the property that it offers. But now we'll get to the real meat. Over to Mark. And deeper dive.
Well, if we can get that slide back up, I actually wanted to just spend a little bit of time on it. So Tony, a few moments ago, you said, "Oh, DSQL scales up," right? And it's funny that you use that word "up" because that is how databases have typically scaled, right? If you need to do more work per second, then you need more resources. Databases are typically on a single instance, and so the only way to get more resources is to get a bigger box, right? And the cool thing about this slide is everything here scales out. It scales horizontally, right? And so just to spend a minute on one of these components, we'll pick the query processor, so that second from the top. So as Shyam was saying, that's where SQL happens. That's where we have a modified copy of Postgres running there. And so you may be wondering, okay, what is that? Is that like a 4XL or like a 16XL? How many transactions can it do? And the answer is it can do one. Every single one of those QPs is like a Lambda function.
Oh, wow.
And so if you open 100 connections, you have 100 of those boxes. And 33 of them may be in AZ1 and 34 in AZ2 and so on, or they all might be in the same zone, depending on how you've configured your application. And so DSQL is going to just take care of that for you. And you don't need to a priori say, I want this much capacity, right? You just connect, and that's our job to make sure that we have enough capacity.
And that comparison you made to Lambda is actually interesting because we use a lot of that same security and isolation technology that Lambda uses with Firecracker. So, I said this is a multi-tenant shared fleet. Well, we have to make sure that all of your data is fully isolated and secure from other customers. And so we use, again, at scale tested, battle tested technology with Firecracker, where all of these query processors are running in their own micro virtual machine. When your query is done, it's just torn down, poof, your data's gone, and we load your catalog again in another query processor that's spun up for the next transaction.
Yeah, and this should be music to people's ears who manage databases. When you think about a self-managed database or an on-prem database, even if you think just a managed database with something like RDS, to then move to something like this, which takes you to another level again, it's really, really powerful. We've got some questions as well, which I'd just love to share with you before we move on, because we've got a few in here actually. So we've got schizophrenic web developer, 3 nines and 5 9 availability. I'm assuming that's to do with, is it single region and multi-region, the availability? the 2 different 9s yet.
Yes. So on a single region, cluster is automatically distributed, all layers that I just showed you, or in 3 availability zones. And so you get 4 nines availability. When you're doing multi-region, then you've got essentially a clone of that same architecture in the other region.
Yeah.
And all data, and we'll get to that event eventually on there, that the data is actually not eventually consistent. Everything that you commit, whether it's in a single region or a multi-region, is instantly available in all the AZs that cluster operates in, or both regions that it operates in. So you don't actually have to wait. Again, going back to that effortlessness, you're not waiting for things to catch up. You're not waiting for, can I fail over now? Your applications just treat all, both endpoints or all the availability zones are all equivalent in availability terms, or sometimes in database terms we talk about it as active architecture. There's not a single point you're reading or writing from. All of them are active all the time, and the strict consistency actually unlocks that as well.
And that's how you get the high availability. 5 nines is it's impressive. So, and then if we've got Victor, automatic failure recovery would be realized from the sandbox instance for on a future. That's why I worked on it, to improve recovery purposes. I'm not too sure what that means, to be fair. So let's bring this one up. So managing connections, a connection pool. So that's an interesting one. How do you manage connections? And also, what is the max connections you can handle? Is there, have you actually got to an upper point on max connection to anybody?
Yeah. Mark, you want to take that? I can give you the first line answer, which is, virtually unlimited scalability. That's an architectural principle. We keep pushing the boundary. Right now you can have over 100 terabytes of data. 10,000 connections is what we allow right now. You can talk to us if you have applications that are more demanding. Again, from an architectural perspective, the system can handle 10,000, 20,000, 100,000 connections. We put practical limits because, again, operationally you don't want to just have unlimited, your clients just open up unlimited connections. You may have other reasons to control that, but from a architectural perspective, just reach out to us if you have greater needs. The system really will just scale. Mark, you can talk about how that works on the front end.
Go take a look at how many connections should I open to instance-based Postgres. It's not a lot. Connections are heavyweight, right? They consume a bunch of resources. And so, as Shyam was saying, we have just pretty high default limits because DSQL is designed to scale, and we don't really want our customers to muck about with requesting quota increases. So the default limit of 10,000 is just so much higher than you would expect from an instance-based service. But if you need more, just reach out to us through the quotas tool, and we can increase it.
Yeah, and we've got another one here, actually. So do you need a connection pool for Aurora DSQL?
Yeah. Let me take that one. So this can be a topic of confusion because there's sort of client-side connection pooling, like you might do with your driver, like in your Java or in your Python code, and then there is pooling at the PG bouncer or RDS proxy layer.
Yeah.
And so for the former, we do recommend you have connection pooling, and the reason for that is connections are not free. Right, so you have to, at a minimum, set up a TLS connection to DSQL. You have to log into the service. If you're using prepared statements, then your application will have to go and prepare a bunch of statements. And all of these operations just really eat into time, right? And so you're going to spend a bunch of milliseconds on getting these connections ready. And therefore, if you're trying to process an API request, then that's time that your customers have to wait for. So the good news is that most connection poolers that we've looked at just work with DSQL and no problem, right? So they're actually pretty simple to deal with. On the server side pooling, we actually do not recommend that you try and use a PG bouncer or something like that. Just connect as many as you need. A lot of the reason for that is that connections have historically been slow and a constrained resource. We have 10,000. Some some applications have been trying to work around a much lower limit, like 100, right? And they may have many applications that they're, application hosts that they're scaling out. And each of these needs to have a connection pool. And so how big is that pool? Is it 10? Is it 15? Is it 100? And it can be really tricky to sort of figure out the math there to say that, each of these hosts can burst to have enough connections that they need. But if you have, for example, a pool of 110 hosts, now you need 1,000. And so if the instance can't do 1,000 or opening 1,000 connections really hurts performance, then you may want to have a middle box, a pooler, that sort of multiplexes onto the service. That's just not necessary with DSQL. If you use a pooler, you're just going to add latency. You're just going to add another thing to manage, to scale, something that can fail. And DSQL is designed for having a lot of connections. So yeah, that's the story.
That makes sense. And 10,000 is a lot. I've managed databases for years. 10,000 is a lot of connections. Yeah, you're very lucky to see if you're in the thousands, really. And if you are, you're typically looking at going, why is it in the thousands? Typically, you've got, opening connection pools with far too many connections, what you don't need. So yeah, that is an interesting one. We'll do one more quick question because I think this one's an interesting one before we do some demos. Lambda has cold start. Does Aurora have something like cold start when it's not used? So I think when you were talking before about these query processors being a bit like Lambdas, as you're firing, is there a concept of a cold start, or is it just like poof, straight away?
Yeah, so the thing about Lambda is that Lambda has the secure execution environment that uses Firecracker virtual machines, right? And then there's many customers with many functions, right? And so it's really tricky to just keep these sandboxes sort of assigned to any one function, because now that's occupying part of the service's capacity, right? The cool thing about DSQL is there is only one function, right? The next sandbox that we're going to create and use is also going to be Postgres. Like, that's what our service is. And so we actually just keep this very large generic pool. And when you connect to DSQL, we're just sort of picking one out of the list. And so we don't have that same cold start experience. With that said, as I mentioned before, you're going to have the best performance on DSQL if you use a connection pooler and just make sure that all of that work, that it's fast, but it still takes more than 0 milliseconds, right? So just get that out of the critical path for your service.
Yeah, that's great. Good answer.
Maybe I can amend that one thing, Mark, just for transparency. So we also, one of the advantages you get with DSQL is we scale down to 0, right? Which means when you're not using the database, you don't pay for anything. But let's say you don't pay for the database, or as in you don't use the database for days on end or something like that. So at that point, we will do some optimizations where you might feel some cold start, but not in the 5-minute, 1 hour time frame. But as you think about like, okay, I just haven't touched this database for days on end, then there may be, a few seconds where we're just refreshing all the resources for that so that, we can bring it back.
Yeah, that makes sense. Yeah. So if someone was, like you say, not using it, and then they did a performance test where they just went woof and thrown a load at it, right. Potentially you may see a little, it wouldn't be a truly reflective of potentially the performance, that little start bit. Yeah, that makes sense. I think, all right, let's get doing some demos because I'm just conscious of time now. We're halfway through. So, and okay. We have some great demos showing us getting going with it. So,
okay. So this is the DSQL landing page, and I'm going to make a cluster. So, pay attention 007. Done. That's it.
And so it literally is as simple as that. Yeah. And
it's as simple as that.
Yeah.
So this cluster, it should go to the created state in 2 minutes or less. Maybe let's.
And I guess people who are familiar with like potentially using RDS and stuff, where you're, the concept of building an Aurora cluster, for example, which a lot of people will be common with, in there you're actually building, you're physically building machines, apart from if you're using a serverless edition. So this does differ, doesn't it? What you're getting. And hence also the speed, like you say, 2 minutes to spin it up.
Yeah. So let me do that a little bit more slowly. So there's really two two sections when you make a single region cluster. Do you want deletion protection? Do you want to change the key that we encrypt your data with?
Yeah.
And do you want to give it some tags?
That's it. So there's no instance size. There's no storage size.
Yeah, no security groups, no VPC settings, no maintenance windows, none of that stuff, right? This is a managed offering, and yeah, we're not going to pick an instance size, right? Because as I said, every single DSQL cluster out there is going to do exactly the same thing. If you open a connection, you get one of these Firecracker sandboxes running Postgres. Okay.
And interesting what you said there. You don't do no security group. So how are you managing connectivity to it?
Yeah, so you don't have security groups for your S3 tables, right? You don't have security groups for your DynamoDB tables. So your S3 buckets, DynamoDB tables.
Yeah, and I suppose you're in the same realms, aren't you, if you think of it as a service?
Yeah, so DSQL is a managed service. You talk to DSQL using TLS. Login is done using IAM authentication, which we'll see in a minute. And if you want to have tighter controls, you can set up things like private link. But the default experience looks a lot like connecting to S3 or DynamoDB.
Yeah.
Okay, so that cluster we made is ready to go. Just for simplicity of the demo, I've actually pre-made a single region cluster that just has some tables and stuff that we're going to use. And if you click on your cluster, you can connect to it using Cloud Shell, which is just a pretty convenient way to get going. And you'll see that we're in here. And we have...
You're in Postgres already, right?
It's
and
Postgres.
We're using what you connected there, DSQL Connect. So
yeah, let me show you that quickly. So DSQL Connect is simply just a shell script that we've got installed in Cloud Shell. And you will see that it generates this thing called an authentication token.
Yeah.
And an authentication token is like a bridge between the IAM world and the Postgres world, right? So Postgres has various authentication mechanisms. You can say, I want to connect with the username and password. You can say, I want to connect with the certificate. There's a bunch of options. Postgres out of the box doesn't know anything about AWS or IAM. And so we have this little bridge called these authentication tokens. And they're generated by the AWS SDK or by the AWS CLI. They're done locally, so there's no service call or anything like that. And they give you this sort of one-time token that you can use to log in. And so all this wrapper does is it makes one of these tokens, and then it runs pSQL, which is the Postgres command line tool. If you install Postgres like with Homebrew or with whatever your package manager is, you get this, and it sets the password to this auth token. So that's all it is.
And that makes sense then. Yeah, anyone who's, I guess, familiar with Postgres and what pSQL is, pSQL is just a command prompt to connect into Postgres as an engine. Yeah. Okay, that's cool. And then we're just creating some tables here by the looks of it.
So it's just pretty straightforward stuff.
And I guess if you've come from a relational background and understanding the syntax you're using here, very familiar stuff. What being used?
Yeah, nothing here should be a surprise.
Yeah.
Okay, so I just need to swap my screen share for a minute.
Yeah.
So we can get to the shell.
And you're going to your command prompt now, aren't you? Yeah.
That's right. Yeah. Okay, how about that?
Yeah, there we go.
We good? Okay.
Yep.
So I'm just going to show off joins because we just want to emphasize that this is a relational database, right? So you can have multiple tables that can have, rows can have identifiers like primary keys, and then you can have secondary tables, and you can write sort of queries that join against them. So we have a like a blog set up here, right? We have a table of posts. We have some users. I put Mark and Sham in here, and then we have a bunch of comments, right? So I'm just going to register a post in our system. And there we have it. Now, what we might want to do is say, hey, write me a query where I want to print out like the title of the post and then like the user's name who made the comment and then what their comment was, right? So let me go. So we'll say post title, user name, and then the comment. So we're going to go from the post table, then we're going to join to the comments table. And then we're going to join to the user table. There we go.
Yeah, great.
A great joke. So again, like nothing fancy here if you're familiar with relational databases. You just do SQL and, what's happening here behind the scenes is this connection is to one of those query processes that we saw earlier in the talk. And it's going to go and figure out like, hey, given this query, how do I go and run a distributed query over the underlying storage, right? Now, it may be that the posts are stored on one host, right? It may be that the users are stored on one host. And then the query processor is going to have to go and figure out, like, how do I build an efficient query plan that goes and, scans the post table and it scans the comments table and it uses the right indexes. And then when it has to do joins, it does efficient like batch lookups to the other storage hosts.
That makes sense. And I guess from a performance tuning perspective, if you was trying to look at your queries and you wanted to see if they're using user indexes, can you use things like explain plans like you would just do in Postgres? Yeah, exactly.
Yep.
Great. So
there we go.
This is where you can start to see if you're familiar. And also the settings you're using there as well, the pSQL settings to, expand this, change the expand display and turning that on and off. So yeah, it's really cool.
Yeah. Okay.
I feel compelled at this point just to point out, like, all of this, if you're thinking of using a database and you had said, oh, I'm going to use Postgres, like it's effectively the same experience, except you're not installing it, you're not managing it, you're not scaling it. So it's just, it's literally the same experience. And, from a technical standpoint, the query processor doesn't even know that it's potentially talking to hundreds of different storage nodes and pulling all of that together. So that's why the explain just works as is, right? So,
and you're talking really, if you're a startup as well, like you are starting with zero, aren't you? And if you think of it, what you're building, you can go right up to what you were just talking about,
exactly.
Virtually unlimited, I think we said, didn't we, is the term for it. So
yeah, oftentimes you're sort of, you start with the project, then you go, oh, now I hit certain limits, I got to refactor my database, I got to shard it, etc., etc. And we're really trying to just take away all of that pain through the life cycle of, development and business growth.
So anyone paying attention to the explain plan would have seen a nested loop there. I just feel compelled to say that I didn't add an index on any of the post IDs and the user IDs, and so
we've just not got lots of data in there.
Yeah, I had one row, but if we added an index, you would have seen a more efficient plan. Okay, so let's quickly talk about isolation. So I have two terminals over here. They're both connected to the same DSQL. And we have a simple banking system, right? And so we can read the same data from both sides. And what we're going to do now is we're going to shuffle all of the money, so $100 from the first account to the second account. And so our end state is going to be ID1 has 0 and ID2 has 200. And I just want to show that like normal database isolation rules work. And what's magical about this is this top shell is literally connected to a different virtual machine, right? And so a lot of the way that databases would actually typically implement this is that they would have the rules, the visibility rules, sort of running within that single process, and it's keeping track of who can see what. we have the same effect, but the implementation is just totally different. Okay, so just to give everybody the 101, when I run a single statement like this, I'm actually starting a transaction, running a statement, and then ending the transaction, right? And we can do that more explicitly by using the begin and commit commands. So the first thing I'm going to do is, actually, let me do this quickly. Okay, so our second connection, the one at the bottom, has also started a transaction. They're both in a transaction. And the top one is going to deduct that $100 from the first account. And then it's going to do an increment to the second account. And then you see what you expect, right? First one is 200, second one is 100. Now, what might be surprising is, what do you think I will see when I run the select statement again in the bottom?
I mean, if you've not committed the other one, you would expect to see the same. Yeah.
That's right. Okay, so let's commit that. And then let's double check. Yeah. Data got committed. Okay. What happens if I run the select again now?
You would hopefully see the 200 because now it's been committed. But hey, nope. Interesting, because it's the same transaction as before. Yeah.
That's right. So the second transaction has a frozen moment in time.
Yeah.
Right. And this is what we mean by isolation when we say ACID, database ACID, atomicity, consistency, isolation. This transaction is isolated. And this is a really key property for databases, and it's why they're so wonderful to program against, because concurrency is really hard to reason about. And here we just, like, the database takes care of it. So if we commit this transaction and we run the query again, oh dear, my Wi-Fi failed. But there we go.
What would happen in if in that current transaction where you had a partial transaction, you were trying to update the same data? You try to do the same update. What would you get then? Would you get a computer says no?
That's a great question. So let's do this. Okay. Okay. Nope. Computer says no.
Yeah.
Right. And if we do a read, you'll see that we've just lost 100 from the one.
Yeah. And then at that point, you need to program that to handle that conflict. Yeah, that makes sense. That's
okay. Good. So this update that we're doing is actually a good example of how you can create conflicts in the database, right? And pgbench has a bunch of these built-in workloads that it can run. And if I do show script update, you'll see an example, right? So this simple update workload starts a transaction, and it changes the account balance by some random delta. Then it reads the updated balance, then it inserts into a history table.
Mm-hmm.
And so you can just run pgbench and say, here's my DSQL cluster, go and run this script, and you can get some sort of performance numbers out of it.
Yeah.
Now, I actually did that a little bit earlier. So over here, I had 1,000 clients running, 10 threads. I was running for 60 seconds, and I was getting 43,000 TPS. So, before that, a minute before that, I was getting 39,000 almost, right? And so this is just an example of I'm running the same thing over and over again, and DSQL's detecting that there's load, and it's adding more capacity to deal with the increased demands. These are pretty impressive numbers.
Yeah, they are. Yeah, they're good. I use pgbench quite a bit. It's a good tool. If anyone is familiar with Postgres, pgbench is it's nice.
Let's just look at another quick demo. So this is actually a demo that Sham built called Ping Pong. And the way this demo works is there's a single table with a single row, and it has a value, an integer value. And the rules of the game is the client is going to just read this value in a busy loop. So it's just going to say select, 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 select. And it keeps track of what the last value that it wrote was. So I put 1 in there, and then I wait. Read, I see 1. Read, I see 1. Read, I see 1, over and over again.
Mm-hmm.
And as soon as it sees a higher value than what it wrote, it's going to increment by 1 and write again. So the idea is that you have two clients. One puts 1 in, and the other one sees 1 and it writes 2. And then it sees 2, 2, 2, 2, 2. And then the other one sees, 2's there, and it writes 2, 2, 2, 2. Okay. And so this first host is going to initialize the game.
Mm-hmm.
And each of these periods that are being printed out is a read to say, hey, I looked in the table and the value's unchanged. Now, the dots are moving along.
The ping pong ball has been thrown to the other side and it's waiting for the ball to come back.
Yeah. Okay. The second
then
client
you
is
need to kick it
going to do
off
the
on
exact same
another
thing, right? So you'll see that the cluster IDs here are the same, 6E8.
Yeah.
And now the game is actually going to start. And so they're just writing out the number that they see. And they go back and forth.
Yeah.
Okay, so we're going to add a third client into the mix. And this is going to sort of show us, again, that conflict example that we had, right? Because what's going to happen now is one of them is going to write 1, and then there's going to be 2 clients saying, 1's there, and then they're both going to try and write 2, and only 1 will succeed. And so you'll start to see a bunch of X's. And what the X's mean are that, hey, I tried to write the update, but like I got that conflict error, and I tried again.
Yeah, there you go. Yeah.
So this is just a cool little demo. You can there should be a link to the GitHub repo if you want to run it yourself.
Yeah, Prasad's going to share that in the chat, so it will also be in our show notes as well afterwards. So we'll give it that a try.
Okay.
And in full transparency, it would have been embarrassing to share after I wrote it. So Mark actually made it proper, readable, usable code and high quality.
Can we have a quick look at the code now? Is there any way you could just show it quickly?
Yeah, I can do that.
Was it a Q developer code, or did you actually write it from scratch?
It was a Claude port of Sham's code.
Excellent.
So there's just a table called ping pong. You can run initialize, and it'll just drop and recreate the table, and it'll put that initial row in. And when you start the game, we update the row to this initial value of 1. Give me a sec. And here's the game loop. So we open a session. We read the row. If the row has changed, then we try and write a new one, and then we commit. Otherwise, we print a period. So it's super simple. You can read the code. It's on GitHub. Okay. I want to quickly show the exact same demo with multi-region. So here you will see that the identifiers are different, but it's the exact same setup, right? So the top host, which is running in US West 2, is going to connect. This time the periods are coming a little bit faster because I'm connected from an EC2 instance, not my laptop at work. So like the latency is a bit faster. And then the second instance is actually running in US East 1. And again, it's connected to a different cluster. Oops.
Yeah, different cluster in a different region for this one. Yeah.
Yeah, I think my laptop Wi-Fi failed at some point. Give me a second.
Awesome. At least we see it's a nice live demo, which is always good. No videos here.
I got the region wrong.
And what is the region on the top one? Is the region
US West 2.
US West 2, and then we're in US East 1. There we go. And we can see it. Cool.
So you can see here, this is a US East 1. And so this is kind of the magic of multi-region. So let me quickly skip back to my web browser.
So while you're doing that, we've got a couple of questions here, which we'll take. Let's have a look what there is. So we've got, so yeah, we talked about this earlier, didn't we? Aurora is Postgres compatible, so you can use the same client driver. So that's correct. Yep, you can. We talked about that, so that's really nice. Yep.
The only thing to know is the IAM authentication that we talked about, but from a driver protocol type system, all of that is Postgres. We're actually running Postgres. We don't support the full set of everything Postgres. If you're looking for like a fully 100% compatible with 16.1 or something, we have Aurora Postgres and Aurora MySQL. With this one, we support all the core functions you'd expect from a relational database.
And one other question just before we move on as well. You mentioned no downtime during upgrades. So how do you update the underlying catalog with no downtime when major version releases? That's very a DBA question, I think, from I think he's crazy DBA. So do you want to pick that one up, Mark? So you just handle it. It's just there's nothing you need to do, because major release upgrades can be time consuming, can't they?
Yeah, there's the thing to wrap your head around is that there is no instance, right? There is nothing really to upgrade. And so every time you connect, so earlier in the demo, I got disconnected, right? Yeah. And the reason for that is I actually opened a bunch of these connections earlier this morning, and eventually they expired. And so with an instance-based database, you just really connect and you leave the connection open as long as you would like. Because if that connection fails, probably the database is down, right? Yeah. Whereas with DSQL, we actually kill sessions after an hour, because we really want customers to get used to having to reconnect all the time, because that's how you're going to get the best availability. Yeah. This actually comes back to that connection pooling question. What we really recommend customers do is use a connection pooler as a library. By the way, this is not code you have to write, but these connection poolers can be configured to, for example, have a max lifetime or reconnect or test if the connection's still alive before they hand it out to the application. And so with just a little bit of configuration, this is quite an easy pattern to obey. But if you're using it, then you're actually getting new connections all the time. And so we've actually made scaling look the same as failure, look the same as patching, right? They're all the same to us. Yeah. You just keep connecting. That's sort of one piece. The second piece is a little bit deeper to answer in this context, but the underlying catalog needs to be sort of made backwards compatible so that you can have simultaneously clients connected at version 1 and clients connected at version 2, and they can both coexist in the same world. We're actually only offering a single version at the moment. When we offer newer versions, we're going to also update our documentation to explain how customers can coordinate and upgrade. But the experience we will have at that time is not one where you have to take downtime. It's one where connecting new connections gives you a newer version. And again, once we're ready to share more information, we'll do that.
Yeah, no, that sounds interesting. But back to demo, because we've got about 5 minutes left. So
okay, yeah, let me just show you what making a multi-region cluster looks like. This looks exactly the same as the single region experience, but there's this new section over here. And you will see that there are 2 pieces of information you have to fill in. So one is the witness region. So I'm in US West 2 right now. And so I can pick either US East 2 or US East 1 as the supported witness regions. And then the second piece of information, which is which other cluster do I want to peer to? So if you remember from the ping pong demo, the one client was connected to cluster A and the other client was connected to cluster B. So the clusters are independent. And from that architecture slide, if you remember, we have the query processes and the transaction processes and storage and the journal. In a multi-region setting, you have independent clusters. The thing that's shared is the journal. And so the journal is the transaction log that is shared between clusters. But other than that, they are fully independent clusters running in either region.
And can you have more than one region? Is it just one mapping, one?
So at the moment, we only support what we call a 2-region plus 1 witness region configuration. Yep. So let me actually just quickly do this. So I'm going to pick US East 2 and then create a cluster. And this cluster is now it's pending, right? Yep. Like DSQL can't complete the creation because it doesn't know which other cluster you're trying to peer with.
Makes sense.
So if we click this button over here, we can make a new cluster, and I'm going to pick US East 1. And now it pre-fills in the information. So like, okay, this is a new cluster. It's going to be in US East 1. You can see in the URL bar here. The witness is the one we picked, and this is the new cluster that we just made in US West 2. So we create this cluster. And now it's also going to be waiting because that first cluster didn't yet know about the ID of the original one. And so we've just got a handy button here that is going to send you back to US West 2. You click create, and now they will both go into the creating state, and they'll come up together in kind of a wormhole way, right? And everything I showed you before, like joins, the ping pong demo, the consistency. So what if we had 3 clients running? Like all of that stuff just works in a multi-region setting.
It's awesome. And I guess a multi-region setup as well. You're talking a few minutes for that to create as well. It's not.
Yeah, 2 minutes or less.
2 minutes. Wow, it's really impressive, isn't it? I'm just looking at the time now. We've got a hard close in a couple of minutes, so we'll start to wrap up the show now. But thanks for the demo. That was really useful. I like that ping pong one, and Prasad has shared that as well. We'll also share it in our show notes, so you'll see it on LinkedIn. I will post our show notes. Also, if you've just joined halfway through, there'll be catch up for this as well. Straight after the show, you'll be able to go and take a look at it. It'll be there after the show as well. So if you want to go and have a look at some of these demos and see what Mark was doing, you can do that and go and watch it back on playback. And see, even walk through. I was going to say walk through, create a cluster, but it's like 2 or 3 clicks, isn't it? When you think about creating a cluster, it's pretty simple to do. So we'll be here again next week. So 11th of August, Lydia will be your host, and we'll be talking about Valkey and Redis. And that'll be at 5 p.m. CET, 8 a.m. Pacific time, 11 a.m. Eastern time. Same locations, Twitch TV.aws and YouTube AWS events. We've also got our email address, which Prasad will pop in there into the chat as well. If you ever want to ask us anything or talk about topics you want to see or ask about stuff you've seen on the show, just email that address as well. And we've also got a community page as well. That community page is just under a rebuild at the moment, and you'll see it is redirecting to builder.aws.com. Essentially, the community.aws pages are moving to builder.aws.com. So all of our content is still there. All the information on our past shows is still there. So that'll be getting updated over the coming days. So again, just look out for information as I send it through on LinkedIn. And thanks again for everybody who posted in the show. Really great questions. I'm sorry I didn't get to all of them as well. So if there's anything burning there you do want answering, send it to us. Maybe even, fire to me on LinkedIn. I'll find you the answer, or you can do it to that shared email address. And finally, thanks to Shyam and Mark. Great show and a big celebration for our 100th. It was a really good show for the 100th show. Thanks for being on here. And it was a really nice builder show, actually. It was good. Mixture of the two. So thanks a lot, guys.
Yeah, congrats on the 100th. Thank you, Tony, and thanks, Mark, for the cool demo. I guess my only takeaway, last point I'd just say for the audience is you can try this right now. We've got a generous free tier as well, so you can just go in, start trying it away. A few minutes, you're off to Postgres and off to the races. So go ahead, try it out. Let us know what you think.
Yeah, excellent. Cheers, everyone.